In some problems, like we can find in Activity 2.8, we'll have questions that deal with rather large data sets. So for instance, if we scroll down to the bottom of the page here, we'll see a pretty sizable data set, which can eat up a lot of class time getting students to enter all that information in, and it can also lead to problems if students make minor typos, things like that. So one nice feature about Desmos is that we can shortcut some of that and get around some of those minor issues by giving students a link to a pre-built activity in Desmos. So in this case, this is a direct link to an activity that I've already built for Activity 2.8. If I click on this link, this will take me right to information that I've already entered in and saved in Desmos. In this case, it's the data already entered in, my viewing window already set for an appropriate X and Y scale so that I can see all of my data points. If this is something you want to share with students, or if you create something that you save and want to share, you can use this share graph icon, and Desmos will automatically generate a link to that activity. One of the nice things is when you give students this link, or as you're interacting with this, you can change things in this sheet. So for instance, let's say I just delete everything here. Everything's gone, but it's not gone forever because you haven't changed the original document. So I could still go back to this link, enter it in again, or follow that link, and all the information is preserved. So the original activity is intact no matter what individual students do. So if they get really off the rails, delete things, break something, you can always reload and go back to that original starting point. Having this information preloaded into Desmos, again, saves time and also essentially takes care of question 1, where we're asked to graph these data points on an appropriately scaled coordinate axis. What we can do then is go ahead and jump ahead a little bit here to question 7, part B, where we're asked to now actually construct the regression line. So in between, students would be coming up manually with an approximate regression line. Now what we'll do is actually use Desmos itself to create the least squares regression line for this data. Again, the textbook is going to show us how we could do that with a graphing calculator, but using Desmos, in my opinion, this process is actually quite a bit easier. So we just need to click to open a new cell, and then constructing the least squares regression equation is as simple as knowing the form of the function that we want to create. So in this case, we want a linear function, so we're going to enter in something of the form y equals mx plus b. In this case, however, my x values are actually defined as w variables, just to remain consistent with how the data was presented in the problem. So instead of y equals mx plus b, I'll have y equals mw plus b. So what we'll do is enter in y1. Anytime we enter a number after a variable, Desmos will automatically turn that into a subscript for us. So now what we're doing is referencing that second column from our table above. Rather than using an equal sign, what we'll do is use the tilde sign, which is located right next to the 1 key on your calculator. So if you hold Shift and then press that tilde key, and then m, which is a constant we haven't defined yet, w subscript 1 plus b. So m and b are just constants, and since we're using this squiggly line notation, that tilde notation, what we're doing is telling Desmos we want to construct that regression equation, and what it'll do is determine what our values for m and b should be to generate that least squares regression line. In addition to giving us the values for m and b and graphing that least squares regression line in over our data, we're also going to see values for r and r squared calculated, so we can use those values, reference those to start drawing some conclusions about the fit of our plot. We can also, while they're not included initially, include the residuals for our plot. So if we click this plot button next to residuals, a couple things will happen. We'll see a new column added to our data set, which will be our list of residuals. And there are new points added over here, which this actually works out well that it decided to produce those in the same color, which can start to be a little confusing. So if we click and hold on this green circle, we could change the color of these points to red to help us distinguish the residuals that we're now plotting relative to the original data. Some of those residuals will show up below the x-axis, which we can't see. So if we click and drag somewhere on our graph, we could move our view so that now we get the full picture of all of those residuals. In question 8a, we're asked to add something to our graph. What we want to do is produce our scatter plot, which we already have, along with the least squares regression line and the original line, or the original equation that you would have found in problem 3, part C. So to clean up our graph a little bit, I'm going to click on this red circle, which will hide all of those residuals. You could turn those back on as soon as you wanted to start interacting with those or coming up with any sort of conclusions based off those, analyzing those points. But just for the sake of clarity, we can hide those, and opening up a new cell or clicking on a new cell, we can go ahead and plot that equation that we would have found in question 3 part C, which would be y equals 0.36w minus 47. So now what we can do, and in this case it did plot this graph as a different color, which again we could change, or we could change that to be dashed, dotted, just to show our actual least squares regression line versus this approximate answer we came up with earlier. We can have both of those lines graphed and discuss any similarities or differences between those as we're asked to do in question 8. The last thing we'll take a look at in this case will be question 10. So we want to, in this case, see what's going to happen if we construct our least squares regression line after eliminating our outlier, which is in this case the point 240, 15. So what we want to do is delete that outlier, recalculate our regression line and correlation coefficient, and then answer some additional questions. So again, for clarity's sake, we can turn off the graph of this equation that we would have come up with in question 3. So now we're only looking at our data points and our least squares regression line. If we want to visually see that point that we're trying to remove, it would be this one far out from that pattern. If we click on that point, it'll actually give us the x and y coordinates, and we can do that with any of these different points. So we can make sure we're visually understanding the point that we're removing. In this case, we run into a situation where Desmos will operate a little bit differently than our calculator. We won't actually be removing that data point from our set. Instead, what we'll be doing is manipulating that point so that it's a better fit for our line. So for instance, if we came through and actually deleted our values of 240 and 15, our regression would break. So we need all those data points in there, but what we can do is manipulate any outlier to put it more in line with the rest of our values. As this stands, I can't do that. I can't manipulate this point, but if I come up to this green circle and click on this, I can turn on this drag option or enable that. I can set things so that I can change my x coordinate, y coordinate for a given point, or the cross will let me manipulate both the x and y values simultaneously, so essentially I can drag any point anywhere I want. So if we can keep our eye on that point 240, 15, I can come over here and click and drag this value until it's pretty much right on top of that regression line. So this is a little bit different than the approach that the textbook would have us use. We haven't deleted it. Instead, we have we've dragged that point until it's perfectly in line, or as close to perfect as we can get, with the rest of our regression equation. So our values may be a little off from what we get in the textbook, but should still be fairly close. We should still come up with very similar values for our slope and intercept. Our R value is still going to be much stronger than before. And then we could continue to do that with other points. We could see how dragging any point away from the line or closer to the line would impact our value for R, that correlation coefficient.